So the final operator we're going to talk about in this introductory section about operators in RxJava is going to be the terminal operator. And as we'll see, the terminal operator is used to terminate a Flux stream, which will have the side effect of triggering all the other processing of all the other operators in the stream. And we're going to look at the subscribe operator. There's a whole slew of overloaded subscribe operators. We're going to talk about one of them and then give a few forward references to other ones that are interesting. So what does subscribe do? It subscribes a consumer and runnables to a Flux. And as you can see here, the operator, along with the stuff that it's going to pass as parameters, is going to consume all the elements in the sequence if they work. It'll also handle any error conditions that may occur, and it'll also handle any completion events that may occur. And you can see here it takes 3 parameters. The consumer is the one that handles the normal case, the on-next events. The error consumer handles the error event if it arises, and the runnable complete consumer is going to be used to handle the completion event if it occurs. And the consumer, of course, is a functional interface we've seen before, and hopefully you're familiar with runnable by now. It's the functional interface that's been around since day one, which just has a single run method that takes no parameters and returns no values. So it's perfect for doing the completion event notification. This particular instance of subscribe requests unbounded demand. So remember we talked about back pressure earlier, where you can have a subscriber say, hey, I don't want you to just send me data as quickly as you can. I just want you to send me n of these items before I ask you for the next chunk, the next tranche, the next batch. Well, this particular subscribe method says, throw caution to the wind and just send publisher, send data as fast as you possibly can and up to forever. So using long max value indicates this will go on forever. Signals that are emitted to the subscribe method are represented by this regular expression that we've seen before, where we're going to get either 0 to up to infinity number of on-next events, which will come, of course, through the consumer first parameter, followed by optionally either 1 on complete method through the runnable or 1 on error event hook method called back through the error consumer. So now you can finally see how the semantics that we talked about earlier for reactive streams and publisher-subscriber interaction is expressed through the subscribe method, which is the terminal operator. What's returned is something called a disposable, which is essentially a means to keep track of a task or a resource that needs to be canceled and or disposed. So the disposables, as we'll see when we get a little further along, can actually be collected up and stuck in something called a composite or disposable composite. And if you put a bunch of disposables into this composite disposable, which is like a collection of disposables, then all these disposables can be disposed in one fell swoop. And basically the idea here is to be able to give these resources back to the underlying Java virtual machine when we're done with some kind of Flux stream. If you fail to dispose stuff, it's harder for the garbage collector to know when these things can be collected. So when you call subscribe in a stream, and you must call subscribe ultimately in a stream in order for it to do anything, it triggers all the processing. So it's kind of like the green flag at the start of a road race where you say, start your engines, you're off to the races. So all the other stuff in this stream, like from iterable and map and so on, never occurs until subscribe is reached. And you can see what happens here is we're going to take a list of big fractions, we're going to multiply them by some big constant, and then we're going to use subscribe, and subscribe is going to deal with the results that come through. So let's take a look at what it does. For the normal processing, in other words, the on next event hook method, we just take the item that was the big fraction and convert it to a mixed string and stick it into a string buffer or a string builder. If something goes wrong, we append the word error. We probably should have done something a little bit more here, but I didn't want to have it not fit on a slide. We should probably gotten the error that occurred and printed that out. And then finally, on the onComplete event, we're going to display the results of everything we've been accumulating here in this string buffer or string builder. So that's where we're going to actually print the results out. So nice kind of clean, concise way of handling everything. Very important to note, calling this method is not guaranteed to block the calling thread, the caller thread. So it's possible, especially when you start using asynchrony that we talked about before when we talked about the async task barrier, for subscribe to return, and there's a bunch of stuff going on in the background, which is now going to be handled asynchronously in some background thread somewhere. And that's very important to note. This does not block the calling thread, because if you're not aware of this, you can get yourself in all kinds of situations where your program will fall off the end of main, and there's a bunch of asynchronous stuff running around, and it'll be terminated prematurely. The semantics of subscribe are one of the motivations for the async task barrier framework. So we talked about this before. Async task barrier is what we can use to wait for a bunch of asynchronous things to finish without having to block each of the asynchronous operations from running concurrently. So that's one of the motivations. There's other ways to deal with this as well, but this is a common one. There's a bunch of other versions of subscribe. There's probably maybe a half dozen different versions of subscribe that mix and match different parameters. One of the more interesting ones that we will look at later is one where you can pass a custom consumer that will support back pressure. So you can do all kinds of cool, clever things using your subscription consumer, and we'll show some examples. We'll walk through some examples later as we get further along. RxJava has a subscribe operator that works pretty much the same way that the one from Project Reactor works. One of the things that RxJava has that Project Reactor doesn't have is it has a blocking subscribe method that's built in, which at some level is kind of antithetical to the whole purpose of having reactive streams with asynchrony. However, for testing and debugging purposes, it can be very helpful. So that's one of the things that's kind of missing from Project Reactor, which again is what motivated the creation of that mechanism that would deal with asynchronous task barrier semantics. So that's the end of the first discussion of key terminal operators in the Flux class. We'll undoubtedly discuss other ways of doing this later in the course.